So let's see. So if I look at my sequence, it's not getting hugely larger or smaller. So that means I'm probably adding the same number. And if I look at this, I can figure out what I'm adding by going negative. Okay, let me get a pen here. Negative 25, right? Take this term, take the second term, and minus the first term. So if I take negative 25 minus a negative 40, and if you guys don't, you can put it into your calculator. You can actually put it into your calculator. Put that exactly into your calculator, and you should get plus 15. Okay, and I can do the same thing here. I can do negative 10 minus negative 25, and I should get plus 15, because it's going from a bigger negative to a smaller negative. So that means I'm getting closer to 0, so I'm adding a number. I'm not getting further away from a number. And then I've got 5 minus a minus 10, and those all equal 15. Okay, so the difference between them is 15, which means this is a geometric. No. Let me start over again. It's not geometric. I'm adding. If I'm adding, this is arithmetic. And I have a common difference of 15. And then it wants the next 3 terms, so I'm just going to add 15, right? So 5 plus 15 is 20, and 20 plus 15 is 35, and 35 plus 15 is 50. Okay? And that's how I'm going to do this. So I'm going to go to the next one, and I'm going to look at it. Now, look, I know that it's not adding the same number, because the difference between 4 and 8 is not the same as the difference between 16 and 32, right? So I'm not adding the same number. So I can say, how do I get from 4 to 8 that's not adding? Well, I can say that's multiplying by 2. And 8 times 2 is 16, so I'm multiplying by 2 here. And 16 times 2 is 32, so guess what? I'm multiplying by 2 there. Does that make sense? Are we okay? So if I'm multiplying by the same number, that means that this is geometric with a common ratio of 2. And then, let's see, 32 times 2 is 64. Times 2 is 128. Times 2 is, that's a good question. 128 times 2. Someone has it in here. Let me look. I don't think that 128 times 2 is 512. So I don't think that's right. 128 times 2. 256. Okay, there we go. All right, 256. Okay? Questions so far? Are we okay? Awesome. And then the next one is getting extremely large also, right? It went 63 to 189 is not the same as the difference between 7 and 21. So that means I'm probably multiplying by something. So what do I multiply 7 by to get negative 21? Negative 3. And negative 21 times negative 3 is 63. And if you put in your calculator, you did 63 times negative 3, I would get negative 189. So since I'm multiplying by the same number, this is geometric again with a common ratio of negative 3. And then the next 3 terms, let's see if I can figure this out really quick. 189 is 567 minus 1701, or negative 1701, and then 5,103. Okay? And then the last number 4, what am I doing this time? It looks like they're all the same. So how do I get from 19 to 24, 24 to 29, 29 to 34? Let's see, 19, 20, 22 to 3, plus 5, plus 5, plus 5, beautiful. So this is arithmetic, and I have a common difference of 5. So my next term is going to be 39, 44, 49, ... Okay? Questions? Is everyone okay with that?
Yes.
Lovely. Not too bad? Okay. So you are going to have a checkpoint on this. And I will get it done and made today. I don't have it made yet, so I had to write myself a note. So I will get it done and made today, and it will be available. I'll just have it made available until the 4th, when we come back from spring break. Wow, from winter break. Sorry, I can't say Christmas break because, not everyone celebrates Christmas, so it's winter break. Okay. So we're moving on. We're still going to be working with sequences. We're still going to be finding common differences. We may be finding the next 3 terms, but we're really going to be finding common differences. Today, we're only going to be working with arithmetic sequences, so we're only going to worry about adding the same number. Is everyone okay with that? So we're only working with arithmetic today. I can't even talk today. This is going to be a good day today. So we're only going to be working with arithmetic today. A sequence is an ordered list of numbers, which we defined last class, so we just typed it in. An arithmetic sequence is a sequence in which the difference between constant and consecutive terms is constant. So the difference between these terms, here to here, and here to here, and here to here, and here to here, and here to here, they're all the same difference. So they may have a constant interval, which in this case, I'm adding 5 every time, right? From 0 to 5, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. I'm just adding 5 every time. So that's an arithmetic sequence. Is there any questions on that? That's all we're going to do right now. We are just going to tell whether the sequence is arithmetic. And if it is, I'm going to find the next 2 terms, not 3. So only if it's arithmetic am I going to find the next 2 terms. Okay, so if I look at number 1 here, I'm just going to zoom in on it. How do I get from -7 to -1, -1 to 5, 5 to 11, and 11 to 17? Again, I can take these 2 numbers, the first 2 numbers, and subtract them, right? That's the best way to find it. Or unless you can just see the difference, you can, well, basically if you're just seeing the difference, you're doing it mentally in your mind. You're subtracting one from the other. Like if I looked at these 2 right here, let me highlight it in a different color. If I look at what's the difference between 17 and 11, what are you going to do in your brain? My brain's going to go 17 minus 11 is 6, right? So that's the same thing I'm doing with -1 and -7, only I'm saying -1 minus a -7 equals 6, right? So how do I get between, what am I doing to there? I'm adding 6. How am I getting from -1 to 5? Well, I'm going to add 6. And 5 to 11, and add 6. So this is it arithmetic? Yes. Yes, it's arithmetic. Okay, and my next 2 terms, 17 plus 6, 17, 20, 23. And 23 plus 6 should be 29. Done. Okay, that's it. That's all we're going to do for the first one. So this second one here, let me see. Oh, I am definitely not adding the same number. How do I know? Well, what do I add to 1 to get 4 would be plus 3. Well, 64 plus 3 is not 256, right? So this is not arithmetic. I totally spelled that wrong, but it's not arithmetic, okay? So I don't have to do anything else to it if it's not arithmetic. Now it's your turn. So find out if it's arithmetic If it is, find the next two terms. Let me slide this up here. Okay, guys, let's go ahead and look at this one. If I look at A, it's getting smaller because my first number is 67, my last number is 43, so I know I'm going to be subtracting some number. So what do I do to get from 67 to 59? Well, I'm subtracting 8. And from 59 to 51, I'm subtracting 8. And 51 to 43, subtracting 8, not adding 8. If I was adding 8, my numbers would be getting bigger. I hope you guys understand that fact. So since they're getting smaller, remember I'm going from left to right. The dot's after the 43. So this is my first term, second term, third term, fourth term, fifth, and sixth would be after here. Yeah, you just read it backwards. That's it. It's okay. You're not the only one that did that. So this is arithmetic. Yes, it is. And my next term, my common difference, you already know, is plus 8, which I don't think it actually asked me to identify the class. It didn't. Okay. It just said, tell me if it's arithmetic and find the next two terms. So my next term, 43, would be 35, and then 27. I think that's right. I did the math in my head, so I think that's right. Yeah, good. Okay, and then from looking at your guys' math, good job. I hope you guys did your math right too. So looking at B, also, again, it's getting smaller, right? It's going from 31 to 22 and then dot. So that means it's going to be negative. So what's my difference here? How do I get from 31 to 28? Well, I subtract 3. And from 28 to 25, I subtract 3. 25, subtract 3. So for the next two terms, I'm also going to subtract 3, which this means, yes, it's arithmetic, right? Because I'm subtracting, right? I'm subtracting the same number. So my next term should be 22, 19, and then 16. Okay. Questions? Awesome. You guys are awesome. Okay, we have a few more notes to talk about. Sorry, I need to get my notes here, which means I need my pictures. Sorry. I took pictures of my notes so I didn't have to write them down on a piece of paper. I know, so sad. To graph an arithmetic sequence, create a table. So we're going to create a table. Okay. Where the terms, T-E-R-M, terms, position in the sequence is the X value. Beautiful. Okay, so that means here's my sequence here, 0, 5, 10, 15, 20, 25. And I'm going to use this, my sequence. The sequence are my Y values. So I'm just going to go ahead and put them in there. 0, sorry, that's my first one. 5, 10, 15, 20, 25, right? So this is my first term. This is my second term. This is my third term, fourth term, fifth term, sixth term, Is there a question on how I... Oh, that's okay, Esther, not a problem. That happens sometimes. Is there a question on how I set up the table? Right? So my Y terms are just my sequence. The X terms just start at 1 because it's my 0 is my first term. 5 is my second term. 10 is my third term. That's how I got my X values, 1, 2, 3, 4, 5. Okay? Pretty simple. So to graph these, I'm just going to graph them. There's no way for you guys to show me on the chat box. Oh. How to do this. So I'm just going to go ahead and, I guess, do it. So I'm going to make a table, right? So I have my X value and my Y value. And I've got my first term is -2. And my second term is 1. And my third term is 4. And my fourth term is 7. I almost wanted to say fifth term. Is 7. So I've got my table here. Okay, and I'm going to plot my point. Now I'm going to plot my points. Now I have points to plot. I have my x value and my y value. I have 1, -2. So I'm going to go to 1, -2. And I have 2, 1. So 1, 2, 1. Okay. And 3, 4. 1, 2, 3. 1, 2, 3, 4. And 4. That was 4, 5, 6, 7. Let me make sure that's right. 1, 2, 3, 4. 2, 3, 4, 5, 6. Yeah, there we go. 6, 7. I can't connect it with a dot with a line. I can't connect it with a line because my sequence doesn't tell me it's all the points in between. So I just have to have these points and these points only, so it's a discrete graph. And that's it. Done. That's all I'm going to do. Okay? And I'm going to do the same thing with the next problem. I have my table. 1, 2, 3, 4. I got 5 terms this time. So this is x, this is y. 1, 2, 3, 4, 5. Okay, so I've got my first term is -9. My second term is 1. My third term is 11. Fourth term is 21. 1, 2, 3, 4, 5 is 31. I can't count very well today. Sorry, you guys. And now I'm going to graph it just like I did. So I have 1, -9. And I know that -9 is not quite on my graph. I'm just going to kind of approximate where it's at. It's almost to -10. So it'd be like somewhere in there. And 2, 1. And again, 1's not on my graph, so I'm going to approximate it. It's going to be somewhere in there, right? And 3, 1, 2, 3, 11 should be somewhere in there. And 4, 21, 10, 21 should be somewhere in there. And 5, 31 should be somewhere in there. So there's my 5 points right there. That's all. Is there any questions on how to make a table from a sequence? Okay. Awesome. You guys are awesome today. You guys are awesome every day. Oh, I am so sorry. Okay. So now we're going to talk about the equations we're going to write. And these is the important part. We're going to write a recursive equation and an explicit equation. You guys have already written explicit equations. And we're going to do some more today. You just didn't know that's what it was called. And we're going to write your recursive equations. We're going to start with the recursive equations. I happen to think they're easier to write. They're just not as useful. There we go. They're not as useful as a explicit equation. So my recursive equation will say this. F of x, that's my function at x, right, is going to equal f of x minus 1 plus or minus my common difference, whatever my common difference is. So if it is -6, it would be -6. If it was +6, it would be +6. So that's why I put plus or minus my common difference. And then I have to say f of, I'm going to say 1 equals some number. And now I'm going to explain this all in words, okay? So this is my next term. What this says is my next term equals my previous term, plus my common difference, right? Common difference. R-E-N-C-E. And this is my starting point. Notice I didn't say my 0th term, I said my starting point. And my starting point in a sequence is always the first term. Okay? So it says my next term equals my previous term plus my common difference. And in order for me to figure out a recursive equation, this is great. So it says my next term equals my previous term plus or minus some number, which is kind of how we figured out our sequences. But the most important part in this equation is my starting point here. If I don't tell them where to start, am I going to be able to add a number to something and get my sequence? That's why you have to have your starting point. You have to tell it where to start at. Yeah, I'm going to add this number. I'm going to add 51 every single time. Well, where am I starting at? You have to know what you're adding 51 to the first time in order to have a recursive equation, or else it doesn't work. You can't get the sequence. Okay? So explicit equation you guys have seen before, right? So this is, okay, try it one more time. This is going to be f of x equals mx plus b, right? You've saw that, you've seen it, you've had a checkpoint on it. M is my common difference. And b is my, this is where it's a little different then. This is my 0th term, right? My 0th term. Okay. Did I leave myself enough room? Let me just, oh, beautiful. Okay, so if you guys need to take a picture of this, this is probably the most important thing we've talked about so far. Are these two equations that you're going to need to know. So if you haven't got them written down, Mauricio's here. Make sure that you write them down. Okay? So here we go. It says, what does it say? Write the recursive and explicit equation for each sequence, then find a sub 100. That means find the 100th term of this sequence. Okay? So in order to do this, I need to find my common difference, because if you look at here, both of these equations, both my recursive and my explicit, call for, I guess I'm going to have to erase this. And beautiful. That was gorgeous. Calls for my common difference. Both of them, I have to know what my common difference is. So I need to know how I'm getting from one term to the other. So I need my common difference on both of them. Okay. For one of them, I need my starting point, right? My starting point is my first term. So I'm going to write that. Starting point, I know, is first term. Okay, the first term of my sequence is my starting point. And then for the other equation, I need my 0th term. So I also have to find my 0th term. So I have to find all this stuff, okay, in order to write these equations. But yeah, we can do that. We've done all of these individually in little different parts. So I'm going to turn this into a table, and I'm going to turn it into a table very, very simply by doing this. First term, second term, third term, fourth term. Okay? And then I know I need to find my 0th term. So what am I doing to get from, I think I must have had a typo, just so you guys know. There is a typo on this problem. Can someone tell me what the typo is? Anybody? I'm pretty sure that this is supposed to be a 43. Okay, so how am I getting from 13 to 23 and 23 to 33 and 33 to 43? What am I doing every time? Adding 10. That is beautiful. Yes, adding 10. So my common difference is 10. I want to slide up, but I don't want my equations to go off the page. And what's my 0th term? Oh, good. You already answered the question. I haven't even answered it. My 0th term is, what do I add 10 to get 13? Well, that would be 3. Okay, so now I think I have all the pieces I need to write both equations. So we're going to start with the recursive first. So recursive. That is so not a C. Let's try this one more time. Recursive. Okay, so my recursive equation always starts out with f of x. Always. And it's always f of x equals f of x minus 1. Always, always, always. Okay? All right, and then what am I doing? Well, then I'm adding my common difference. So I'm adding plus 10. So f of x equals f of x minus 1 plus 10. And then I need my starting point. So f of 1 equals 13. How do I know it's 13? Well, f of 1 is what? Oh, that was not what I wanted to do. F of 1 is 13. 13. Yeah, right? It's all given to me in my sequence that I have. Once I turned it into a table, it's all right there. Okay? So then the next thing it wants me to do is find my explicit equation. Sorry, you guys. Explicit equation, right? And I'm going to do f of x again equals, this time it says my common difference times x, so 10x. And plus my 0th term. My 0th term is 3, so that would be plus 3. And then it says the last thing it says to do is find a of 100. Well, that's like saying finding f of 100. And I think we've done this. So that's 10 times 100 plus 3. What's 10 times 100? 1,000? Plus 3, so a sub 100 is going to equal 1,003. Done. Okay. I'm doing this a couple, 4 or 5 times, maybe 6 times before I'm letting you guys do this. So make sure you're asking questions and you're following along and answering answering the questions I ask in the chat box. So I know that you get it, okay? So when it's your turn, you can understand what we're doing, okay? So for number 2, I'm going to do the same thing. I'm going to make a table, right? And I have term 1, 2, 3, 4, and 5. And then I'm going to need my 0th term eventually. So what am I doing to get from one term to the next every time? What am I doing? That is very correct, Alex. Good. Can someone else answer that question for me? What am I doing to get from one term to the next term?
Adding 5.
Adding 5. That is awesome. Yes, I am adding 5. So if I'm adding 5, that's beautiful. What is my 0th term? What number do I add 5 to get 1? A little harder question, right?
-4?
Yes, beautiful. -4. So now I have all the pieces I need to write my equations. I am not going to write recursive again. I hope you guys are okay with that because I'm just going to write it on the same line here. So recursive is right here. So I'm going to do f of x equals, my next term equals my previous term plus 5. And then f of 1 equals
1.
1. Yep, I was going to highlight it, but you guys already got it. F of 1 equals 1. Okay, and then my explicit equation is going to be f of x equals, my common difference is 5. So 5x, and then my 0th term is minus 4. And then I'm going to find, what am I going to find? Oh, f of 100 equals 5 times 100 minus 4. 5 times 100 is 500 minus 4. So a sub 100 is going to be 496. Is that what it is? 496. Yeah, that's it. 496. How do you guys feel about it so far? You feel okay so far?
We do one more.
We're gonna. Oh, I'm. Oh, no, I'm not. I want to just make sure that. Sorry. That you are, these two definitions that we went over, we highlighted stuff and we put them in here, that we make sure that all of this stuff gets in our two equations. All of this stuff here gets in both of my equations, okay? So we need to make sure that we have all the pieces, especially in the recursive equation, because it has so many pieces to it, and all of those pieces have to be in there to make sure that it's correct. Just make sure that all of those pieces are in there, okay? And that's all I really wanted to say about that. So, got some more to do. Don't worry about it. I've got, see, look, I'm going to do 4 more problems and then before I let you guys try it, okay? Oh, dang. Oh, well. We're going to deal with me writing in the, So I'm going to turn my sequence into a table by saying first term, second term, third term, fourth term, fifth term, right? So what am I doing to get from -5 to -7, -7 to -9, -9 to -11, -11 to -13? What am I doing every time? Yes, Alex, good. I am subtracting 2 every time. Okay? So what would my 0th term be? What number do I subtract 2 from to get -5? Well, that's -3. So my recursive equation is going to be my next term equals my previous term minus 2. And f of 1 is going to equal, right here, here's f of 1, going to equal -5. And then we have my explicit formula. It's going to be f of x equals -2x minus 3. And then they want me to find f of 100. That's going to be -2 times 100 minus 3, which is going to be -200 minus 3, or -203. questions?
No.
We're okay? Is it kind of making a little bit of sense? So I'm going to tell you, I think on the checkpoint, when we get to that, we're not doing it until tomorrow. We're going to review this again some other way. I don't know how yet. But I think the checkpoint has, it's going to be, I'm just going to tell, instead of me trying to remember what it is, I'm just going to tell you, it's going to be just like the homework you're doing today. So your checkpoint will be just like your homework you're doing today. How's that sound? That way you know, so when you're doing the check, you're like, oh, this is what my checkpoint's going to be. I can do this. Okay? So next, we're going to turn this into a table, right? Sorry that I'm kind of having to write under the, I'll try and write small. 1, 2, 3, 4th term, and then I need to find my 0th term. So what am I doing to get from 16 to 23 and 23 to 30 and 30 to 37? 30 to 37 is adding 7, 16, 7, and 20, 20. Yeah, adding 7. So I'm adding 7 every time. So what would I add 7 to get 16? 9. So my 0th term should be 9. Because my difference between here should also be plus 7, right? So my recursive equation is going to be, to get my next term, I take my previous term and I add 7. And then my starting point is going to, f of 1 equals, right here, f of, sorry, I didn't mean to erase that. I meant to highlight it. F of 1 is, holy moly, Oli. Let's try and see if I can actually get a highlighter instead of an eraser. There we go. F of 1 is 16. And then I've got, then what do I have? Then I have my explicit equation, which is f of x equals 7x plus 9. And then I want to find what f of 100. 100 equals 7 times 100 plus 9, which is 700 plus 9, or 709. Okay, so let's try number, what number are we trying now? Number 5. Okay, so I'm going to make a table. And I've got my first term, second term, third term, 4th term, 0th term. How do I get from 30 to 24, 24 to 18, 18 to 12? Well, I think I am subtracting 6 every time.
Subtract 6.
Yep, good. And what number do I subtract 6 from to get 30? I think that should be 36.
36.
Yeah. Nice job. So I've got my my recursive equation, my explicit equation. Okay, so I've got, to get my next term, I take my previous, x minus 1. I take my previous term, and I might minus or add or plus my, add or subtract my common difference. So I'm subtracting 6 this time. And my starting point is f of 1 equals 30. Okay. And then my explicit equation is going to be f of x equals negative 6x plus 36. And then we want to find f of 100, which is negative 6 times 100 plus 36. Negative 600 plus 36. Oh, my Lanta. That's going to be negative 564, I think. 64 and 36 is, yeah, that should be it. 564. Okay. Okay. Last one, and then you guys are going to try it. Are you ready? How are you feeling?
Grandma said you sick.
Okay. So
Is it
we've
at
got,
12?
huh?
Are you adding it by 12?
I am. I'm adding 12. Good. So term 1, 2, 3, 4. So what would my 0th term be?
Negative 3.
Negative what?
I don't know.
You were close.
Negative 3?
Negative 2.
She said that.
Now she said negative 3. It's okay. She did really good, though.
I thought she said it the second time. I swear she said negative 3 first.
And then we're going to write my recursive equation.
Oh, you're doing recursive? I think I'm doing the same thing, and I'm terrible at it. It's not good.
Just so you guys know, my son thinks he's doing the same thing in his college math class right now.
It's like a toddler trying to learn how to swim with nobody else around him. It sucks. And God, Miss Campbell's here. She teaches you.
Oh, you poor child.
I know, right?
F of x.
I love you.
I love you too. Plus 12. And f of 1 equals 10. Sorry about that, you guys. And f of x is going to equal 12x minus 2. So f of 100 is going to be 12 times 100 minus 2. Oh, my Lanta. Okay, so this should be 1200 minus 2, or 1198, I'm pretty sure. Okay. How do you feel? So I'm going to put those next two problems up here, but I'm going to leave so you can see those two. How's that sound? So were you able to make a table?
Yeah, I made a table.
Okay, so we made our table, right? Were you able to find 1, 2, 3, 4? Were you able to find what I'm adding every time?
No.
So the first one's a little hard, right? But what if I look at the second two? What do I add to 191 to get 391? And what do I add to 391 to get 591? So forget the negative 9 to the 191. Let's not look at that one right now. Let's just look at 191 to 391. What am I adding there?
200.
200. Good. Yeah. And from 391 to 591 is 200, right? Well, now we just need to check. And I would just take out your calculator and say, what's 200? Negative 9 plus 200. Or 200 minus 9. It doesn't matter. Guess what I'm going to get?
Huh?
191. So if I put in my calculator, I think I can do it here. I might even be able to hold it up there. 9 minus, oh, I wish it,
191.
yep,
Oh, so it's 200.
it's 200, yeah. So I'm adding 200 every time. And so my 0th term is going to be, so now this time, and kind of how I think about this, if I'm adding 200, I'm going up, I'm adding 200, right? So if I go back to my 0th term, I'm just going to do the opposite of add, because I'm going to draw some lines on here and then I'm going to erase them, okay, you guys? So if I'm going this way, I'm adding, right? But if I'm going to go this way, I'm going to do the opposite of add, which is what? So I'm going to subtract 200. So I'm going to say negative 9 minus 200 to get my 0th term, if you want to kind of think of it that way.
Negative 209.
There you go. Perfect. Did that help a little bit?
Yeah, thank you.
You're so welcome. Negative 209. So now I'm going to erase those. Right now I have all, now can you write the equations? Now that you have that part done, you can write the equations, right?
Yeah.
Because I think that you were doing that already pretty well. So I'm just going to go ahead and do these two: recursive, explicit. So I've got, what do I have? My next term equals my previous term plus 200. And then my starting term, f of 1, equals negative 9. Yeah, okay. And my explicit equation, right, is f of x equals 200x minus 209. Yeesh. So f of 100 is going to be 200 times 100 minus 209, which is, let's see, that's 20,000 minus 209. And I think a whole bunch of you guys have that up here. 19,791. 19,791. That takes me 200. Yep. Okay. Beautiful. Okay. So I'm going to go ahead and do B, and then when we move on to C and D, you can try again on your own. Is that okay? So here we go with making a table again. So we're going to make a table. Right, 1, 2, 3, 4. My 0th term. What am I doing every time on this one? To get from 4 to negative 2, negative 2 to negative 8, and negative 8 to negative 16. I think that I'm subtracting 6 this time. So that means I'm going to add 6 to 4, which gives me 10. So my recursive equation is going to be f of x equals f of x minus 1 minus 6 this time, and f of 1 equals 4. Good. And then my my explicit equation is f of x equals negative 6x plus 10. I have a question for you guys once I get done. Well, let me finish this and then I'll ask when we're not recording. So f of 100 equals negative 6 times 100 plus 10. So that's negative 600 plus 10, which is negative 590. Negative 590. Okay. Alex, are you okay with it being plus 10 and not minus 10? Okay, awesome. Okay, so I'm going to slide this up. I'm going to keep this available for you guys to see for the next two problems so you can. Love you. Bye. Minus So I do want to say this about your recursive equation or your explicit equation. You guys make sure that that you have all the pieces, and how you make sure is you the definitions that we gave on the other page that I said to make sure you had written down or took a picture of. Make sure that you're following those, okay? Mm, 36, I think that's -4. So that would be 40. $360. Okay. There we go. We have just a few minutes left in class, but I wanted to make sure I at least got those done so you could take a picture of them, or you guys know I'm gonna post them on the in the modules page under the completed notes. So I will get those posted today. But make sure, I want to say, I'm gonna just pause on this and go back.